Okay, so this is section 7.4, geometry. If you've got a book and you're following with me on this video, it's page 388 is where we will start. Actually, I'm going to back up a page just to tell you what it's called. It's called Properties of Special Right Triangles. Let's say that again. Properties of Special Parallelograms. So we've talked about parallelograms in general, and now we're going to make them special. Some of them. The ones we're going to be discussing today are the rhombus, the rectangle, and the square. I'm pretty sure the rectangle and the square you're familiar with. Maybe not the rhombus. The rhombus always gets a raw deal. The rhombus is one of the coolest shapes out there, and hardly anybody knows anything about it. It's really awesome. You'll see in just a minute. But a rhombus, remember from yesterday, a parallelogram is just any sort of shape, and you've seen me draw it several times. It's just any sort of a shape like that, where this side's parallel to this one's parallel to this one, as well as several other attributes. Just to remind you, this one's parallel to this one, so this is a fact about parallelograms. If I mark it like that, it's a fact that this equals this, and this equals this. It's a fact that this equals this, and this angle equals this one, if it's a parallelogram, and it is. It's also a fact that if you draw the diagonals, that they cut each other in half, so that this equals this, and this, I'm going to draw it like this, equals this. Huge amount of markings in there. That's a parallelogram in general. Has several properties. Equal opposite sides, parallel opposite sides, bisected diagonals, opposite angles are equal, consecutive angles are supplementary. All of those are true if you have a parallelogram. But if I take that parallelogram and shorten it up, so that it's still leaning over like this, but the sides now, I've taken this thing and squeezed it in like this, and the sides are now the same length. It's still a parallelogram because opposite sides are still equal. They just all happen to be equal to each other. By doing that to this parallelogram in general, by squeezing it down and making sure all the sides are the same length, you've now created a special parallelogram called a rhombus. We're going to abbreviate it RH. Remember, our abbreviation for this shape is just a four-sided figure, whether it looks like a parallelogram or not. That four-sided closed figure, is, regardless of how well you make it, is going to represent parallelogram. So since this is something other than a parallelogram, it's got a little bit more to it, we're going to abbreviate it with a capital RH. It's a rhombus. Now, here's the main and most important thing so far today. A rhombus has all of these attributes, all of these, because a rhombus is first and foremost a parallelogram. So it has equal opposite sides, parallel opposite sides, bisected diagonals, opposite angles are equal to each other. It's got all of those properties in addition to squeezing it down so that all the sides are equal to each other. And when you do that, you'd be amazed at the things that are also true about this, which we'll come back to in a minute. If I take this regular old, this just plain old generic parallelogram with all these properties, and I stand it up straight so that it looks like this, so that we add an extra property to it. That is, it's a parallelogram, that same parallelogram, but now all of its angles are right angles. Now you have a rectangle. It's a parallelogram with four right angles. This could be defined as a parallelogram, first of all, with four equal sides. This could be described as a parallelogram with four right angles. You add those additional properties and you get some amazing things. Now, if you take this plain old generic parallelogram right here and you shorten it up so all its sides are the same and stand it up straight, now you got a square. So a square is the most precise type of quadrilateral that we have. It's got all four sides the same length, making it a rhombus. And it's got all four angles, right angles, making it a rectangle. And so a square is a parallelogram. A square is a rectangular rhombus. Has the properties of both. One thing I forgot about was to tell you we are going to abbreviate rectangle RC. So over here, I could have said a square, I'm sorry, a rectangular rhombus makes a square, which we'll abbreviate SQ. It's the most precise of all. It's got everything. It's got all of these properties because it is first, before anything else, a parallelogram. But it has all the properties of this and this, which we will spend quite a bit of time developing. This has 5 properties. This has 9, actually 10, which we'll all write down in just a minute. But these are the ones we're going to focus our attention on today. These 3 new parallelograms that have additional properties. So I want to talk to you about a rhombus for a few minutes. I'm going to make this one a lot bigger because there's a lot more I've got to put on it. So I'm going to erase all of this. Talk about rhombuses first. Then we'll talk about rectangles. Then we'll talk about how it all comes together with a square. So a rhombus is a parallelogram, first of all. So it has all the properties of a parallelogram. I'm going to make sure these are about the same length. Okay. It's pretty close. Okay. So we know this because it's a rhombus, and its definition is that all of it's a quadrilateral with all 4 sides the same length. Well, it's actually a parallelogram with all 4 sides the same length. I want you to look at the cool things that happen, especially when you draw the diagonals. If you draw that diagonal and this one, first of all, can you tell they're not the same length? This one's a lot shorter than this one. So don't get it into your head they're the same length. But since this thing is a parallelogram, I do know this, that this is as long as this, and this equals this, because parallelograms imply bisected diagonals, right? But here's the additional property, the additional cool thing you get with a rhombus. They do cut each other in half, but they also meet each other in a right angle. So all of those angles in there are all right angles. It doesn't happen in general with these. See this one? This one's rather obtuse. This one's rather acute. But when you shorten it up, those angles come together in such a way that every one of them is a right angle. Now, because of that, all 4 of these triangles are equal to each other. Because look, side, angle, side, side, angle, side, side, angle, side, side, angle, side. They each have a single mark and a double mark side with a right angle in between. They're all equal to each other, and they're all right angles. Right triangles. When things are right triangles, you can apply things like Pythagorean theorem and trigonometry to them. You guys learned trig yet? No? Okay. But you can apply Pythagorean theorem to it. They're all equal to each other, side, 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 or side, angle, side. Because of that, now, do you remember that from parallelograms, which this is, do you remember that this angle is equal to this one because it's a parallelogram? Opposite angles are equal, right? Okay. So if you agree that this angle, this big fat angle down here and this big one up here are equal to each other, and that this triangle equals this one, you get that this angle equals this one. Not true over here. This one's acute, this one's obtuse. But if you squeeze it together so all the sides are the same length, then where the angles where the diagonals come out are the same size. Not only that, since these were equal and we cut them both in half with a diagonal, these are also double marked. So this angle equals this one, equals this one, equals this one. Same is true here. This equals this, and this angle equals this one. Because all the triangles are equal to each other, all their corresponding parts are equal.
What would you call that?
I'm about to write down all of these properties in a formal way. I'm going to put them right down here. Okay? So if you have a rhombus, remember how we said parallelograms imply with the very first day that we did this? Now we're going to say this. Rhombuses imply all of these, first of all. All the things we had over here, all the parallelograms imply over here. Whatever we had, that was supposed to be. Parallelograms imply all of those things we had that first day. There were 5 of them. They're all also true of this. But these, one I'm about to show you, are in addition to these because it's a rhombus. So if you know it's a rhombus, you have perpendicular diagonals. That's only true of rhombuses. Not true of parallelograms in general, but if it's a rhombus, you have perpendicular diagonals. Where the diagonals meet, you get a right angle. That's a formalization of what you were just asking me about, Reagan. Yeah, okay. If you know for sure it's a rhombus, you also have bisected vertex angles. That's this property here, where this angle where the diagonal came out, that gets bisected by a diagonal. Bisected vertex angles with a diagonal. And by its definition, you also have, if it's a rhombus, you have 4 equal sides. That's also a property. Now, the book won't tell you this, but you may use this if you wish, if you need to. If you have rhombuses, if you have a rhombus, you also have 4 equal triangles. This, and this. 4 equal right triangles. This is what the book says you can get away with, and that's great. That's great. But if you want to use this one, you may. If it shortcuts anything that you're trying to do and you don't want to have several. If this helps you, you can. That's also a true thing. So rhombuses have 5 things true about them in addition to these 3. So they got 8. These are only true for rhombuses, but rhombuses are parallelograms. So all of these are true of rhombuses over here. These guys right here are only true if you have a rhombus, not if you just have a parallelogram. Do you understand the difference? Okay. I'm going to erase this because it's being recorded. We're going to talk about rectangles now. You got this down? Okay. So now if you take that generic old parallelogram over there and you stand it up straight so that it now has some right angles in it, you need to understand that this is first, before anything else, a parallelogram. So all 5 of these things that we had for parallelograms are true of this thing too. But now we'll have some additional ones. And we'll go with the definition first. If you have a rectangle, it means 4 right angles. If you draw the diagonals, notice, first of all, that in a regular old generic rectangle like this, they do not cut the angles in half that they come from, because this is a little bit smaller than this one, because it's a little bit longer this way. So that's not true. That was true of rhombuses, but not here. Also notice that the diagonals are not perpendicular, because this one's bigger than this one. This one's obtuse, this one's acute, because it's longer. So that's not going to be the case like it was for rhombuses. However, over here, when it had a plain old regular parallelogram, this diagonal was longer than this one. As you stand it up, this one gets longer while this one gets shorter, until when you stand it right straight up, they are now the same length. So this length right here, that diagonal there, and the entire diagonal here in a rectangle are the same length. They're equal to each other. So if you have a rectangle, you have equal diagonals. But remember, if you have a parallelogram, which this is, if you have a parallelogram, those diagonals are bisected. So if they were equal to begin with, because it came from a rectangle, then when you bisect it, all 4 lengths are the same. So again, the book will not write this, but if you wish to use this for a reason, if you want, that'd be fine if you would like. A rectangle also implies 4 equal diagonal halves. The diagonals, they cut each other in half because it's a parallelogram, and they're equal because it's a rectangle, which means you get 4 equal halves. You may use this for a reason if you like. It's not in the book, but you can use it for me. Everybody okay so far? That's it for rectangles. These are the 2 additional ones, and we get this for a combination of things over here and over here. You get this one as well, but it won't be in the book. So that's the 2 additional things you get for being a rectangle. Now let me erase this, and we'll talk about squares. Squares are rectangles and rhombuses because they stand up straight and they have 4 equal sides. So if you talk about a square, you can have any of those that if you know the thing is a square. If it's a square, you know that it has perpendicular diagonals, for example, because it's a rhombus. So squares imply that too. Boy, that was crappy, but these will have right angles because a square is a rhombus. That's part of its attributes, because these are all the same length. Squares imply perpendicular diagonals just like rhombus do. Squares also imply equal diagonals because it is also a rectangle. Squares also imply bisected vertex angles because squares are rhombuses. That was a property of rhombuses. Squares also have 4 equal sides because they are rhombuses. Squares also have 4 right angles because they are rectangles. Squares also have, what else do they have? They have 4 equal diagonal angles because it is a rectangle. They also have 4 equal right angles because it is a rhombus. In addition to these 5, because it's a parallelogram. Squares have got it all, man. Everything, just about anything you think is true about it is true. So it has all 5 of these because it's a parallelogram. It has this one, this one, this one. Sorry, they should have said right triangles. And this one, because it's a rhombus. It has this property and this property and this property because it's a rectangle. A square is a rectangular rhombus, so it has all the properties of rhombuses, rectangles, and parallelograms. It's got a million of them. It's got a bunch of them. 5 here, and all these are true of squares. Now, that's really nice. If you got a square, you got just about everything. Trying to prove something's a square, that's rough because you have to establish, first of all, that it's a parallelogram. We're using one of the properties we did yesterday. Then you have to find one of the properties that's true that makes it a rectangle, one of these. And then you got to find a property that makes it a rhombus, one of these. So you would have to figure out a property, some property that makes it a parallelogram, and a property that makes it a square. I'm sorry, a rhombus, and a property that makes it a rectangle. Then you could say it's a square. So if you have a square, you got a lot. If you're trying to prove it's a square. Now that you have all the facts, let's see if we can do a couple of, please take a look on page 389 at the top. This is a thing it's called a Venn diagram that links everything all together. So if you're watching this video and you don't have a book, this next discussion is not going to mean a lot to you because I'm not going to put this on the board. It takes forever. But if you do have a book, the top of page 389 kind of sums things up here. If you've got a great big huge toy box in your room and it contains all 4-sided figures ever, you have to imagine it. All 4-sided figures get thrown in there, and you get inside that toy box and start to organize things. You might pick up all the ones that have right angles and throw them in a barrel called rectangles. You might find all the ones that have equal sides and throw them in another barrel called rhombuses. But there might be some that you pick up that have 4 right angles and 4 equal sides, in which case you're going to have those barrels overlap where the squares are. See it? There are some rhombuses that are not squares because they don't have right angles. There are some rectangles that aren't rhombuses because they don't have equal sides. But there are some that have both, and so you have to have an overlap in those 2 barrels. Okay. Take a look at example 1. It says for any rhombus QRST, so they're telling you it's a rhombus. For any rhombus QRST, decide whether the statement is always or sometimes true and draw a diagram explaining your reasoning. Wow. QRST, you don't get a picture. You get no picture. You just get this statement. QRST is a rhombus. Because we know how things are labeled, QRST, either clockwise or counterclockwise from wherever you start. I'll wait for you to sit down. Okay, now everybody focus back on me and what's going on here. Now that she's here, so here we go. It wants to know if Q is always equal to S. All you get is the statement that QRST is a rhombus. All you get is this. We know that it's a rhombus. But based on this and the fact that when we adhere to that rule that you can only go clockwise or counterclockwise, Q hits, then you hit R, then you hit S. Doesn't that mean that Q and S are opposites?
Yes.
Do they always have to be equal if it's a rhombus?
Yes.
Of course, because a rhombus is first, this, and these have that property. So Q and S must always be equal because they are always opposite angles, whether it's a rhombus or just a parallelogram. And a rhombus is a parallelogram. So the answer, the first one is they must always be true. Now, the next one wants to know, does Q have to equal R all the time? Q and R are right next to each other. Is it possible that the angles right next to each other are equal?
Yes.
If you have a rhombus, which this is, that's also a rectangle, then consecutive angles are equal to one another, like Q and R. They're consecutive. They're running right after each other. The question, first of all, is do they have to be equal? No, they don't. Could they be?
Yeah.
Yes. Under what conditions? That QRST is a square. That's when. See what I'm saying? Okay, so you have to look at the statement. Sometimes you maybe want to draw a picture for yourself, but if you understand how things are labeled, then every other one is an opposite pair. Q and S are opposites, R and T are opposites. Q and R are consecutive. Could they be equal? Yes, if they're both right. In which case, this rhombus is also a rectangle, making it a square. Follow on that? That's a lot of thinking through that. Okay? Take a look at example 2. It says, classify the special quadrilateral, explain your reasoning. You've got 4 slashes, one on each side, they're all the same type, that makes it a what?
Rhombus.
Rhombus. Could this thing also be a rectangle? No, because they clearly mark one of the angles as 70 degrees. To be a rectangle, they'd have to all be 90. So this thing is a rhombus only. And it says, explain your reasoning. And you would say, because it has 4 equal sides, it's a rhombus. But because its angles are not right, it is not a rectangle. So it's only a rhombus. You see what I'm saying?
Yep.
Okay, moving on. Look at example 3. We're not going to do this proof. We're just going to accept these properties I gave you as fact and then use them. So example 3 says, find the measures of the numbered angles in rhombus ABCD. So I'm going to put this one up here. I'll erase this first. Hang on. Okay, so what's this thing look like? Leaning over to the right. Got diagonals in it. Did I get that right? Did I put those in the right place?
Yes.
Okay, good. Okay. And it says in the instructions, find the measures of the numbered angles in a rhombus, ABCD. So they're telling you in the words, this thing is a rhombus, so it's got all of its properties. Oh, we've got a 61 down here too. Right here? Is that the 61?
Yeah.
Okay. So, can anybody tell me, just by what you remember about rhombuses, anybody know the size of angle 1? 90. Because it's a rhombus, the diagonals are perpendicular. So we know this is 90. Okay. Can you figure out what angle 3 would be?
Yeah. 61.
61. Because the diagonals that come out of the corners of rhombuses, come out of those vertexes, they cut those angles in half. Not only that, the opposite angles, the whole big angles are equal, so the 2 opposite ones got cut in half the same way. So all 4 of these are 61. So angle 2 is also 61. Do you understand my reasoning?
Yep.
That makes angle 4 what? $29. How come? Because remember, these are right triangles, which means these 2 acute angles have to be complementary. Or in any triangle, they have to have 180. I've used up 90 right there. Used up another 61 right there. Leaves 29 for this guy. See it? Or not? You okay?
Yeah.
Okay, good. So that's the kind of information you have to use the properties for to make some conclusions about the angle sizes and these things. Okay, take a look at the monitoring progress, top of page 391. Monitoring progress. Anybody Anybody tell me what they think the measure of angle 1 is in that diagram? Or even the measure of angle GDE. Maybe you could tell me that one. We know angle E is 118. So what's angle GDE? You go ahead and tell me what you would do, even if you haven't done it in your head. What would you do? Yep. And that would be angle GDE, right?
Yeah.
And they cut that in half because it's a rhombus.
Yeah, angle 1 equals 31.
Yes. Angle 1 equals 31, so does 2, so does 3, so does 4. That make sense to you? Just so that you are aware, here's another way to find angle 1. Something else to think about, just something else to remember from your previous geometry experience. I don't know if these are numbered right, I don't care, they're all the same size. But remember, in a rhombus, this is equal to this, making this triangle right here, it makes it isosceles. So if this is 118, these two angles have to split what's left over evenly because they're base angles of an isosceles triangle. That'd be another way to get at these. By taking 118 from 180 and splitting it in half would give you 1 and 3. Just like 118 from 180 would give you that one, and it's cut in half. But you could use isosceles triangles too, just so you know, that's another avenue to go. Okay, so look at example 4. Now we're talking about rectangles. It says you're building a frame for a window. We got a picture of it right there to the left of example 4 there, so look at it. It says the window will be installed in the opening shown in the diagram. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is a rectangle?
Yeah.
No, you can only assume that it is a parallelogram. That's all you get, because all you know from what's in that diagram is that the opposite side pairs are equal. But that could be true of a picture that looks like this. This is no rectangle, and yet its opposite sides pairs are equal, which is what's in there in that diagram right there. That is no guarantee that it is a rectangle. All we know for sure is that it is a parallelogram. Do you understand this? It has only met one property, and it is not a rectangle property. So the answer to A is no, you cannot be sure, because all the evidence here tells us is that it's a parallelogram. Then it says, you measure the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches each, one each. What can you conclude about the shape of the opening? It is not a rectangle. Because if it were a rectangle, its diagonals would have to be exactly the same measurement. They're off by a bit. So whoever put this frame together was off a little bit in their measurements, and the thing's leaning. You want to put a piece of glass in there, you're going to have to straighten it up first before you do, because it won't fit. You understand what I'm saying to you? There is not, we certainly do not have the evidence to make it a rectangle. As a matter of fact, we know for sure it's not a rectangle because the diagonals are not the same length. You following? Mm-hmm. So if you have a parallelogram first, which we have evidence for, that also has equal diagonals, then you can say it's a rectangle, which we cannot say. Okay, example 5. Example 5 says, in rectangle, so they're telling me now it is. So now we may assume all of its properties. In rectangle QRST, QS, y'all see QS? What's the name for it? What kind of a thing is that, QS?
Diagonal.
A diagonal, okay. QS is 5x minus 31. RT, you all see RT? What is it?
Diagonal.
A diagonal is 2x plus 11. And they want you to find the length of the diagonal, QRT. But they told us it was a rectangle, which means that QS has to equal RT, right? Allowing us to write the equation, 5x minus 31 equals 2x plus 11. That we know as a fact because they told us it was a rectangle, and these two things are diagonals. It means they have to be the same. So if I add 31 to 11, I get 42. And if I take 2x from 5x, I get 3x. And if I divide 3 into 42, I get 14. Which means the lengths of the diagonals, this is not the answer, the lengths of the diagonals are going to be 2 times 14 plus 11, or else 5 times 14 minus 31. Either way, you're going to get the same answer. So it's going to be 28 plus 11 is 39. So both diagonals are 39 in length. Follow that? Because it was a rectangle, we were allowed to set the diagonals equal to each other. One more thing. Using coordinate geometry again. So now we're going back to the grid, which is why I put this on here before I started the video recording so that whoever's watching this could see the grid.
Thank you.
Okay. Okay, so now we're doing the coordinate geometry thing. I'll put the calculations over here or the words or whatever. And it says we've got negative 2, 6, 6, 8, negative 2, 6, that's A. 6, 8. That's B. What is C?
4, 0.
4, 0. That's C. Okay,
Negative 4, negative 2.
and that's D. So if I connect those as carefully as I can with what I think are straight segments, or at least you can use your imagination, hopefully. That thing looks for all the world like a parallelogram, right? But looks aren't enough, so we have to come up with some proofs or some things to verify it. It says decide whether, oh, they're telling us. Sorry, look at the words very carefully so that you know what they're telling us. In example 6, it says decide whether, and it has a parallelogram symbol there. So they're telling you it's a parallelogram. You do not have to establish that. They're telling you it is. That's a fact. It's like a given. So decide whether parallelogram ABCD with these vertices is a rectangle, a rhombus, or a square. Give all names that apply. You don't have to do a proof here. You just have to decide. So first question might be, is the thing a rhombus? Here's how I would decide. To make it a rhombus, all the sides have to be equal, right?
Yep.
So I would say, okay, to get this length right here, it kind of belongs to this right triangle, whose legs are 2 and 8, right?
Yep.
That black part is the hypotenuse of that. Well, take a look at here. 2 and 8. So this is as long as that. I don't have to do any more, which is very cool, because look, if this is as long as this one, which is right next to it, then because they told me it was a parallelogram, I know that this side has to be the same length as this one, and this side has to be the same length as that one. So I don't need to go after these other two, because I already know it's a parallelogram. If I can get 2 consecutive sides to be the same length, I know, and it's a parallelogram, I know I have a rhombus, because if these two are the same, then this has to equal this, and this has to equal this, if it's a parallelogram, which it is. So I've decided it's a rhombus. Now, do you think it's a square?
No.
Not either. All you have to say is angle D and angle B are acute. This is no square. So we're supposed to write down all of the 3 things that apply. This is a rhombus, and that's it. It can't be a rectangle because the right angles aren't there. It can't be a square because the right angles aren't there. Okay? So we've decided it's a rhombus. I was pretty sure that no one would try to even anticipate or even try to think that that thing might be a rectangle or square, but to prove it's a rhombus, you've got to prove one of the attributes of it, and I decided to go after that all sides were equal. Okay? That's it. And here are the practices for those. This is a long one. Sorry. This is 40 questions. A lot of them you just have to look at it and go, yep, I believe that's true. And then give a reason. All those, everything that I erased over there that you were supposed to write along the way, those are the reasons you will use to say, yep, I believe this is a rhombus because, or since it's a rhombus, I believe this is true. Okay? 1 through 7 odd. 13 to 23 odd. 24, 25, 29 to 35. Yes, all of them. Don't be putting odd on there. 29 to 35, all of it. 37 to 42, all of them. 43 to 59, odd. And 65 to 70. Yeah, if you think that's a long assignment, you're right. That's long.
Did you say 65 to 70?
Yes, all of them. Yep. So if you can look at something and make the decision and they don't ask you to explain your reasoning, then you can just move on. Okay? All right. Good luck with that. There you go. Who's ever watching? We're done with this one.